Okay, let's have a look at naming alkanes. In order for us to name organic molecules, we need to have a system that makes it easy and is reproducible. We do this because of the complexity of the organic molecules and because of the sheer number of molecules. So we have what's called a systematic naming system, and this has been set up by the International Union of Pure and Applied Chemistry. In other words, it's the IUPAC system. And it allows us to not only name, but draw and reproduce organic molecules in a way that allows others to do it after us. So how do we go about using this system for alkanes? We have two parts to it. The first part is that we need to find a base, what's called a base name. And the base name has a prefix and a suffix. And the prefix comes from the number of carbons in the longest chain. So if it has one carbon atom in the carbon chain, we have the prefix meth. If it has two, we have eth. 3 is prop. 4 is bute, not but bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. We then also have a look at the suffix, and for all alkanes this will always be ane, A-N-E. Comes from the alkane, the suffix on the alkane. So let's take 3 examples. We have methane, so that means that it's got 1 carbon and it's an alkane. We have hexane, so we have 6 carbons and it's an alkane. And we have decane, 10 carbons and it's an alkane, so we call it decane. We also have another layer of complexity. Let's say that we have an alkane that has branching groups off it. We need to find what are called alkyl groups. And alkyl groups are branches from the main carbon chains. We also call these substituent groups, and they substitute for a hydrogen atom on the main carbon chain. We have a few common groups. We can have a CH3 group, which we call a methyl group, meth meaning 1 carbon. We can have a CH2CH3 group, substituting for our hydrogen, and we call this an ethyl group, eth meaning 2 carbons. We can have 2 lots of CH2 and a CH3. We call this a propyl group, 3 carbons, prop, prefix. We can have 3 lots of CH2 and a CH3, and we call this a butyl group. Now we also have some slightly more complex ones. These ones are straight chained. Let's have a look, if we look at a propyl group that is in a slightly more complex form. Instead of being the 2 lots of CH2 and a CH3, this time we've got a C coming off our main carbon chain, and it's got 2 lots of CH3 coming off it. This one we call an isopropyl group. Rather than a straight propyl group, this is isopropyl. If we look to 4 carbons as our substituent group, if it was straight linear, we call it butyl. If it has a CH3 group coming off the second carbon, we call that an isobutyl group. If the CH3 group is coming off the first carbon that joins onto the main carbon here, we call that a secbutyl group. And finally, if we have 3 CH3 groups coming off the carbon that comes off our main carbon chain, we call that a tertbutyl group. So let's use those 2 principles to start naming some alkanes. And to do that, we use a series of rules. The first rule says look for the longest base chain. And I have a molecule here that has 6 carbons, and then I have another substituent group coming off it. So our first rule says look for the longest base chain. So we've got 1, 2, 3, 4, 5, 6 there, or 1, 2, 3, 4, 5, 6 there. We've got no other possibilities for the longest carbon chain, Therefore, 6 carbons in our base chain will make hexane. We then look for any substituent groups coming off that main carbon chain and we name them. So if we choose our carbon chain, and we can either choose this one going across, 1, 2, 3, 4, 5, 6, our hexane, we have this group coming off, or in this case we can choose our 6 carbon group coming up this way, and therefore we've got our group coming off at this side. Let's make this one easy for ourselves, and we'll call that the main base chain. So we've got hexane, and this group coming off here is 2 carbons, and we call that an ethyl group. 2 carbons, the prefix F, so it's ethyl. Our next step is to select the lowest number system for those substituent groups. So we could choose, and I've named it up here, our carbon chain. We can either have 1, 2, 3, 4, 5, 6 going that way, 1, 2, 3, 4, 5, 6 going this way, 1, 2, 3, 4, 5, 6 going this way, or 1, 2, 3, 4, 5, 6 going this way. Our rule says look for the lowest number system for the substituent groups. So in this case we're going to take our carbon running along the top there horizontally. So we find that 1, 2, 3 is where our ethyl group comes from. So we say that the ethyl is at carbon number 3. And then the final part for this molecule is to write our name in the correct format. And we do that by, first of all, writing the substituent number first. We then have a dash. We then have the substituent name. And then we put the base name. Now we don't need to put it in brackets. So we get for this molecule 3 from the 3 here, ethyl from the ethyl here, hexane from the hexane here. So our molecule that we've drawn is known as 3-ethyl-hexane. And if that's given to any chemist, they can reproduce that structure from that name. So what happens when we've got multiple substituent groups coming off our main carbon chain? One of 2 things can happen. Firstly, we can have identical substituent groups. So in the molecule that I've drawn here, we have our main carbon chain, which is 5 carbons, so it'll be a pentane. And we have 2 methyl groups coming off our main carbon chain at carbon number 2 and number 4. If we have 2 identical groups, we use a prefix di. If we have 3, we use tri. If we have 4, we use tetra. So in this case, we have our pentane, 5 carbons. We have 2 methyl groups, so we have our methyl. And then we use the prefix 2, 4 to denote the positions of our methyl groups. So our methyl group would be off number 2 there and number 4 there. So we call this one 2,4-methyl pentane. Now we can also have substituent groups that differ, in which case we name them alphabetically. So our numbering system still stays from our previous rules, but we name our substituent groups alphabetically. So I've got an example of a molecule here, 4-ethyl. The E comes before the 3-methyl, and then we have octane as our base chain. So remember, the 2 systems are independent. The numbering system is named first. We name...